a lot of amazing people representing amazing organizations. Hopefully there's some great cross-pollination happening today about all things, not just Snorkel, but data and AI. Really the reason we're here, the reason all these octopuses are on the wall, and the reason we've been here and working in this space for the last over 11 years now, counting the Stanford and UW days, is really because we firmly believe that the value of data and data development in AI is still underappreciated. So all of you who are here, hopefully, this sparks some conversation, sparks a little bit of a look ahead to where we strongly believe, and I think the majority of the space now believes a lot of the AI development that actually moves the needle is going to happen, namely around the data. So anyway, hopefully there's some great conversations around that, not just Snorkel, but all things AI and data. So again, pretty exciting that we got the show sold out. Even more exciting and more grateful on our part to the sponsors who made this possible. So again, a huge thank you. I also want to just give a shout out and a thank you to the folks who showed up a day early. We had a bunch of hands-on training and workshop days with our really exciting R3 release. I know we've got some team members here. Anyone want an R3 release? But the real thank you here, and the stuff that is so exciting about yesterday and then about today, hopefully, is really the feedback that this facilitates the interaction. So the R3 release, everything we're doing ahead, it's all based on feedback from folks we work with. That's what we've been doing for over a decade, is we've been not just kind of posting algorithms in archive or chucking software over the wall, but trying to actually build with people. That's how we set up the company, it's how we set up the labs at Stanford and UW. It's how we're trying to, we're trying to facilitate with things like this and the workshops yesterday is actually, leaning in, partnering with you, collaborating with you all, helping you build things that actually cross the chasm from, innovation lab chatbot to real business value, which is, the task, the existential mandate that we're all facing right now together. And then in turn, we're learning from that, and we're trying to incorporate it back into our product and our roadmap. And so you'll see that hopefully reflected in the themes today around our latest stuff. And then hopefully some of the things you say will show up in a value-add way for you in the subsequent instantiations. Okay, so today I'm going to talk, high level. So again, the folks who know better than I do about what's in the product and how it was built are going to give you more detail. Ditto with the research themes, etc. I'm going to talk just kind of some of the high-level themes that we're basing our roadmap, that we're seeing and hearing from many of you in the field, and also seeing kind of from the research world around data development, around data as the programming interface, as you will, for AI. And then I'll talk a little bit about some future themes, and then wrap from there. Cool. So this is something that if you've hung out with Snorkel folks or talked with any of us before, you've heard us say in some form or other before. But the core idea that we've been working on at Stanford, where we spun out of University of Washington, where I'm still on faculty, and then most importantly at the company today, is this broad idea that AI development has kind of been flipped on its head over the last decade, from being about building and tweaking and developing models and algorithms with data as a fixed input. I think of those as these kind of like the Kaggle days of machine learning, where you just kind of, you download a data set, or if you're actually out in the real world, you maybe get a spreadsheet of labeled data tossed over from the line of business, and then data science and AI begins, right? Everything before it, upstream, janitorial, who cares, right? And then the fancy stuff starts, right? That's the attitude where I started my AI journey in, both as a student and a teacher. It's where many of us started. The idea that we've been building around for a while, but that we think is really having its moment today, is this one that's been flipped. The actual development surface is the data that goes in. And by data, I'm using this kind of expansively, and you'll see that filter into how we build, but also this is just a general concept. Data, I include stuff that goes into the context of the models of LLMs, if you're thinking generative, so prompts, but also labeled data points that go into the prompts, which increasingly is what we see with longer context windows, as well as the kind of minimal feedback of thumbs up, thumbs down that goes into an alignment or RLHF DPO style approach, as well as the traditional labeled annotated examples. This document is type A, or here's the prompt and the written response. all of that is data that is going into a model that's already been trained to either prompt it or to tune it or specialize it further. So that's broadly what I mean by data. And the world that we're moving into is increasingly one where the actual LLM and the system that is getting built up around it is not something that the average developer is probably going to touch when they're trying to build or modify a model. Just like, I like the metaphor of an LLM today as like a very smart college student, master's, PhD student, as we see, where some of the latest trends are going with the generalist models. You don't onboard them to your organization and to the use case you want them to perform in by doing brain surgery. You give them training, you give them manuals, you give them examples, right? That's basically the intuition behind data-centric development in AI. So we think the world has already decisively headed that way, and I think we're still catching up even in how we teach AI and data science and we think of our toolkit. That's part of our mission, obviously, but I think it's a much, much bigger idea. I'll just note, some of the leading LLM labs and providers who we also work with and collaborate with on both the company and academic side, whenever they're going for their next model release, the typical turn of the crank is not coming up with a new modification of the transformer architecture, even though we have friends from the lab and elsewhere who do work on that. It's getting new data, new pre-training data, new post-training data, new evaluation data, actually usually in exactly the reverse order. That's the routine, right? And so we're going to see a lot more of that, of reaching for the toolkit of data, not the toolkit of algorithms or models. As sad as that makes me to say, as someone who spent a long time learning that latter toolkit. Where does this become really, really prevalent? I think it's worth noting, a little bit of a distinction in terms of use cases. So if you'll humor me here a little bit, this is in-progress terminology. But a lot of people, I think, are kind of settling on some kind of distinction between, more low-stakes internal, use cases and higher stakes external use cases of some kind. I think Databricks had a wonderful report where they had the distinction of internal versus external. Here I'm tweaking it a little bit because I think the real factor is how accurate on specialized data does your model have to be. And I think there's been this first wave where you actually can get away with somewhat low accuracy and somewhat generic training. Think about a software copilot. Tremendous business value has already been generated, even though obviously we're still in the early innings there. We pay for them internally at Snorkel. And it seems like such a grand challenge problem, which is why we all got so excited about it at the beginning of the the latest Gen AI boom. But really, it's actually somewhat easy with off-the-shelf LLMs. I mean, still behind modern copilots are actually hundreds of specialized models and tons of complex infrastructure. But at a high level, if you think about it in two simple axes, one, the data is not that unique. There's not that many organizations, maybe one or two of you that I know and that we partner with potentially, but not many organizations have their own proprietary coding languages. You can learn a lot of that from public data on the internet that these models are trained on. And importantly, the accuracy requirements are a little bit lower because you're not automatically writing code. It's a copilot setup. You have a very smart human or multiple very smart human programmers. You have layers and layers of redundant tests and compiler checks that adjudicate and buffer errors from going into production. Same thing with internal search. Humans are very used to search not working, top one-shot result being perfect, right? So in these settings where it's kind of generic data, safe, internal, copilot style use cases, you actually can kind of move pretty quickly to production with something that is off the shelf, generalist LLM plus some stuff around it. Again, I'm being very unfairly reductive, but that's kind of a high level view. Myself and I think many others in the space believe that the second wave is where the much larger swath of value lies, and that's where you're actually powering something, you're automating something that's customer facing, that's business facing, where you have to be really accurate. You have to work on your unique data and with your unique domain expertise and for your unique use cases and domains, etc. And that's where you can't just use off the shelf. That's where that proverbial college student needs to actually be onboarded to your unique data and constraints. In other words, the model needs to be specialized, tuned, prompted, aligned with some kind of specialization. And the accuracy requirement is very high. So you actually need to put effort into rigorous evaluation, development, et cetera, to get to that bar where you can put it out in front of a customer or use it to automate a business process. That's critical. So that wave 2, that's what we build for. It's not the only game in town. It's not one or the other, but we think it's going to be where the bulk of the value lies, and it's where we focus. So a couple critical themes. Again, all of these, as you could guess, directly map to a lot of the features that are either in our platform or upcoming. We'll talk about these later today, but I'm going to talk about them high level, kind of with the Snorkel/academic hat on, just as themes that we think are really important in AI in general, and specifically in data-centric AI or AI data development. So number 1, evaluation. Number 2, what I'll call full system tuning and specialization. Number 3, a comment about convergence of interfaces, prompting, tuning, aligning, etc. And number 4, what we think is going to be really critical about capturing not just initial training time, but kind of full cycle human feedback. Who's been thinking about LLM evaluation recently? I won't make you beatbox, just raise your hand. A lot of us are thinking about this, but I think what the actual capabilities that are there are not quite capturing what it takes to get to real enterprise production. Our view, being involved in many production-grade AI projects, both in the generative use case setting and the predictive use case setting, is that there are kind of 3 properties you need for evaluation of those kind of wave 2 use cases. Again, where you need specialization and you need very high guaranteeable accuracy. Number 1, you need evaluation to be specialized. This is just saying that if you're working in a specialized setting, you also need your evaluator to be specialized. The really simple, dumb, but I think very appropriate metaphor is, for a lot of the kind of auto eval, LLM as a judge kind of simplistic solutions out there, which we also contain in our evaluation product and are good starting points, but really don't capture it all. Is if you buy my metaphor that an LLM, kind of trained on the public internet is, kind of like a college student coming on board, or even a PhD who needs to be onboarded, would you then go and grab another random undergrad and have them kind of give the final certification exam? No, you also need a specialized evaluator. In fact, that would be even more important, right? They would need even more training. So eval has to be specialized, not for everything. You could probably check some criteria generically, but for many of the critical ones. Number 2, evaluation has to be fine-grained to be actionable. We did some work back in 2017. This is actually a public paper we did with some of the Apple team. One of the things we learned from partnering with that team way back then, I think is more true than ever today, is when you've got this wide open, generative kind of chatbot setting, you can't just say, what's the accuracy? That's not meaningful, that's not actionable. Instead, you're looking for specific, we call them slices of the data, but think of them as types of queries or types of prompts where it really matters. Maybe when a customer calls about store hours, that's less important than if they call about a critical defect in the product. So making your evaluation protocol and workflow not just specialized, but also fine-grained, so you can monitor the specific types of things that matter for the business or that are likely problem spots. That is the second thing that's critical. And then third of all, making all of this scalable. Scalable while still subject matter expert in the loop. So as you can guess, a lot of that has to do with data. You'll hear about that in at least the way that we've rendered in product later today from folks. But basically, to be specialized with specially tuned evaluators, to be fine-grained with tagging your data into those specific slices you care about, and to do that in a programmatic way with your SMEs versus one click at a time labeling. That's kind of where a lot of the Snorkel approach to programmatic data labeling comes in. But these are higher level ideas. The other point that I'll just make here briefly is, I really think a lot of folks are realizing that we need to move into more of like a test-driven development version of AI. A lot of the early motion was kind of like a shoot first, ask questions later kind of thing of, ship the chatbot and then start figuring out if it actually works or where it works or, more importantly, where it doesn't work. I think we're at a good point now where folks are starting to ask about evaluation before a project starts and thinking about it as the anchor point as it should be. LLMs are so capable out of the box. It's so, it's never been easier in the history of AI to get a great demo. But evaluation has to fast follow for those serious use cases. Evaluation is only as useful as it, in my view, as it leads to action. But if you have that specialized fine-grained eval, that should directly lead you to where you need to then tune or specialize or otherwise develop your model. I'll add one high-level idea here that I think is another one that's not just Snorkel specific, but hopefully of interest, which is this idea that it's not just about tuning or developing LLMs, but LLM systems increasingly. So the simplest but really important and interesting example of this that we see in the space is a basic LLM plus retrieval system. So LLM plus RAG, say. Often the retrieval errors from your retrieval system, your RAG system, not pulling the right data, are actually the first and biggest blocker before you even get to your LLM generating responses. So this idea that you actually have multiple AI systems. You have not just the LLM that's generating a response, you maybe have the retrieval system that's, again, using machine learning, using learn modules to pull the right chunk of the document. That can also mess up. It also will need to be tuned for specialized domains. So this idea that evaluation needs to be the anchor point, and then your development needs to focus not just on prompting or even tuning LLMs, but also on the components that support them, like RAG, for example. One other idea I'll also emphasize is we're going to start seeing a lot more kind of abstraction layers built on top of LLM interfaces. So right now there's a lot of questions of, okay, do I prompt? When do I think about fine-tuning? What about alignment, RLHF, DPO? I've heard about that, etc. We're seeing already a lot of that converge. So prediction for the future, even maybe a year in advance, and hopefully something that we're a part of in an interesting way. But many are already moving in this direction in both the open and closed source, is that these interfaces kind of get abstracted away. And that, I think a year or two from now, developers are mostly going to be thinking about, what instructions and what labeled data points do I give to the LLM to tune it or specialize it or evaluate it for my use case, rather than do I put it into the prompt or do I fine tune or do I align. That's going to be, I think, low level pretty soon. And the key thing is just going to be the data, the examples, the instructions that you put in. And the final idea I'll leave you with, and again, this is something that we're going to be putting a lot of attention into, hopefully getting a lot of feedback, I guess pun intended, from many of you, but is this idea that there are all these valuable but really noisy, messy sources of feedback throughout the system and the lifecycle. The simplest example is what happens once you build some chatbot, you deploy it, and then people start saying thumbs up, thumbs down. It's very well known from many instantiations of AI-based user products, or just internet-based user products, that feedback is very biased and noisy. The people who are your biggest detractors are more likely to actually click thumbs down. The people who are happy will often skip the feedback entirely. So it's not a perfect source of signal, but clearly it's some kind of extremely valuable asset that you want to capture. For those of you that know a little bit of the guts of Snorkel, that a lot of our research is based on this idea of weak supervision, which is taking in noisy signals and cleaning them up. So we have a particular, I guess, opinion here, or set of tools. But regardless of that, capturing the signal and then using it appropriately, we think is going to be incredibly important. So building these, or relying on these kind of platforms of record for human feedback, and then using those variety of signals that come not just during development time when you're asking people to kind of label tuning data or give feedback, but during production time when you're getting live user feedback. I think that's going to be critical for developing AI, but not easy. I think a lot of folks think, oh, we'll just collect those thumbs up, thumbs down, points of feedback. We'll feed it back in. We'll fine tune the model. It'll work great. We know from many iterations of internet products that doesn't work. But it can work if you're smart about it. So that's, I think, is going to be a really interesting theme. We're going to be working on it, but I'm guessing many of you will also be thinking about it. We'd love to hear your thoughts. Okay. I'll give a couple of even kind of further timescales. So everything I talked about was like, both in our product and I think in what we're seeing in the space, kind of right now to over the next, couple of quarters. A little further out, although not that much further out. I'll highlight a couple things that I think are really interesting around data-centric AI. These are things that we're going to be working on. We'd love to partner with many of you. All the stuff that I'm going to mention is stuff that someone from an associated research lab, one of my students or Chris over at Stanford or somewhere, someone is doing some work on, so we're tinkering. We're not yet building in core product, but we think is going to be very important. We probably have probably a couple of papers out there. That's kind of the phase. Two to highlight today is, first of all, this idea of going from multi-component systems to agentic systems and the role that data plays there. This is a simple but I think underappreciated idea. And number two is data for tuning not just training time, but kind of inference time search. Like O1 and other models that are showing that. So on the first one, at a high level, I'll just note that agentic means many things. I'm sure that's another phrase that all of you are not at all tired of hearing, and wishing you could have more people shout agentic at you. So you're welcome. But it's a little bit of a hypey term. I think it sometimes just means company that was funded 6 months ago or less that is making crazy claims. I interpret it mostly as just some more complex, either static or dynamic kind of graph of LLM and tool calls with maybe some memory thrown in. So just instead of having one LLM that you just ask a question to, you now have maybe a chain of non-LLM tools. You can kind of think of this as a spectrum. So if you think about just an LLM as kind of the starting point, I'd argue that an LLM plus RAG system, which I think probably many of you are working on and we're doing a lot on, as I mentioned, is kind of the first step. It's now going from one thing to two things, to a two-component system. And agentic is just kind of going from two to many. If you think about it that way, there's a pretty simple, but I think underappreciated and very critical place where data development fits in, which is as you have more components, you have more places where you need to both evaluate with data and tune and develop with data, right? If you have 10 LLMs that are all calling each other, you now have 10 times as many things to evaluate, and you have a handful of them that you're probably going to need to specialize and tune for your setting. There's a weird thing that's going on in the space. Now I'm just kind of ranting, but yeah, if you'll humor me, where people kind of think that, hey, we have an LLM working at maybe 80, 90, 95%. Maybe if we cascade them together, the accuracy will go up to 100. That's not how any physical or information theoretic system in the history of has ever worked. If you cascade things together, the errors multiply in some form. Now there are exceptions to that, right? Especially if you're throwing in deterministic systems like a SQL query or something that has really robust checks around it. But by and large, you put more pieces together, you have more work to do to get it to work at production grade accuracy, at least in those kind of wave 2 settings where every accuracy point matters. You could probably guess what I'm going to say next, but the key to getting it to work is number 1, evaluation, which is all about data, and number 2, with the hotspots where it's not working well enough, going and tuning those. So that's going to be an area where you're going to see us doing a lot more, and I think it's going to be an increasing focus just for many of us, is basically how do you apply these data-centric techniques to these more complex systems. The second thing that's super interesting, we're seeing with models like OpenAI's O1, and there have been a number of open source follow-ons. We had a paper from the Stanford lab about a month before the O1 release about this inference time scaling phenomenon. But basically this idea that, okay, even after you've trained the model, if you let it think more, if you apply some kind of search approach afterwards, that you can also train a bit and tune a bit with an RL style approach, kind of like AlphaGo and those things that showed us the power of these approaches even years ago, you can get even more performance in pretty incredible ways in certain domains out of these models. The key, though, is that to do this, you need some kind of surprise, surprise labeled data. And if you note where models like O1 are, you can just look at the O1 report, and there's some other papers that have come out recently. They're really good in settings where the labels are easy to get. Now, it's kind of, again, it's almost counterintuitive because some of these areas where labels are easy to get sound really cognitively difficult and impressive, like formal logic and math and coding, etc. But these are all settings where we have really good machinery to basically check correctness and provide a label. In areas where that's harder, like English writing, there aren't meaningful gains from these approaches yet. That's mainly because it's not so easy to get labeled data for tuning them. So I think we're going to see a really interesting frontier of actually getting these kind of post-training approaches to work for all the other domains in the world that probably actually affect many of your businesses, where it's not easy and trivial to get labeled data, but where again labeled data can actually make them work and make incredible things happen. So those are two themes I'll just highlight that are a little further down the road, but I think are going to be super interesting. And with that, I'll wrap, and I'll just note that again we're really excited both through the actual stuff we're building, but also just the general stuff, the general message that we're trying to get out there, that we've been trying to get out there for over a decade, which is that AI is nothing without the data. Developing the data is not some janitorial task that someone gets stuck with, but it's actually really the epicenter of development more than ever before, and it needs to be more programmatic, more like software development. We hope we can help you realize that, and we hope we can all work together to see it realized in the space more broadly. So thanks all for being here, and super excited to chat with many of you today. Thank you.